All right, looks like we are live, and I want to welcome everybody to Standing for Truth. My name is Donny, and I am your host and moderator for tonight's much anticipated debate between Dr. Robert Sungenis and Nathan Erickson on the flat earth. Specifically tonight, flat earth is on trial, and I am pumped for this debate. This is our first official flat earth debate on the Standing for Truth channel, and I have to say I am thrilled to have Dr. Robert Sungenis and Nathan to engage this topic. Why don't we break the ice and get to know our guests a little bit before we get into the debate itself? Nathan, it is your first time here on the channel, and so why don't we start with you? Nathan, firstly, thanks for being here. How you doing today, and a little bit about yourself.
It is absolutely a pleasure to be here, Donnie. Thank you so much for hosting this. Doing wonderful. Really eager to present some flat earth information, hoping that it can help support and affirm the Bible. And so personally, I'm a student. I work at a grocery store. I was going for nutritional cardiology, so like food supply is big to me, and heart disease reversal. I have an angiogram that I do often tend to show, which is this actually has to do with this is a reversal of heart disease, the #1 cause of death in our country, and it's showing reversal. Someone who had late-stage heart disease, and then they reversed it with plant-exclusive eating, which is another topic, but I think is like original biblical eating, has tremendous effects on health. That said, I'm now currently going for astrophysics because because of evolution, was stopped from writing a paper. So astrophysics is what I'm going for to get more into cosmology and trying to clarify in the academic system more biblical cosmology, because I do believe that the Bible is the most accurate describer of our cosmology. And so that is a little bit about myself, and I'm a biblical literalist, and I love God's word and his creation and the people that we get to spend our lives with. And so I think the more that we know about creation, about ourselves, about the word, and about our creator, the better off society can be for all of us. And we have the technology and communications networks to help share all of this stuff, so we can have, I believe, really a very good life in accordance with the Bible. And I'm, again, very honored to be here. So thank you to both of you, Robert and Donnie, both of you, very much. I appreciate it a lot. So.
Nathan, thank you very much for that introduction. It is great to have you here for tonight's debate. I do have your channel linked in the description box for anybody interested in seeing more from you. Dr. Sungenis, great to have you back as well. You're definitely no stranger to debates, nor a stranger to Standing for Truth. You were just here last month, so I'm keeping you busy for an excellent debate on geocentrism. That was a fantastic debate. I went through that a few times, and so I highly recommend people check that out. So, Robert, how you doing? Good to see you, and a little bit about yourself.
I'm doing well, and I'm privileged to be here as well, as Nathan says he is. I enjoy debates, and I enjoy mostly, trying to get to the truth. It's tough. It's tough on earth trying to get to the truth. We do have a source of truth, the Bible, and Nathan and I both believe in the Bible, literally. And so we have a good platform to start from. We won't be talking past each other, I don't think. And so at least we can start from there. I did write a book. Let me see, what is it, 2023? We talked about time going fast. I think I wrote this in 2018, 5 years ago. And that's this book called, let me see if I can get the glare out of there. Flat Earth, Flat Wrong. That's a pretty obvious title, huh? Flat Earth, Flat Wrong. No guesswork there. An historical, biblical, and scientific analysis of flat Earth theory. So, and I think that's like 750 pages, if I remember correctly. anyway, so I have been at this for probably older than you guys are. I've been at this for. I used to go to the chats with the Fish brothers, the Gish brothers, rather. Dwayne Gish and his brother back in the 70s. Okay. I was in college. And so that's where I, sunk my teeth into this whole cosmology thing and evolution, creation, all that stuff. So I've been at this for a while. But then the flat earth thing cropped up out of nowhere. And we had made a movie called The Principle in 2014, and it showed in U.S. theaters, I think about 15 U.S. theaters, and we were pushing against the Copernican cosmology. The Earth is out there in the remote recesses of space. Carl Sagan. Cosmology, and we didn't get a good reception by the public. But at the same time, the flat Earth thing came along out of nowhere. It's like, what are you guys doing here? But it's been here before. It's like it sort of goes up and down. I don't know what actually causes it to become popular, but it became very popular when our movie came out. We thought it was a conspiracy against our movie because they were trying to make us look stupid or something. I don't know. But that's when I first got involved with the flat earth thing. And then a institution asked me to write a book against the flat earth from a biblical, historical, and scientific perspective, and paid me for it. So, it was a joy to do it. And if somebody actually paid me to do it, so couldn't refuse that one. And then that ended up being, like I said, 750 pages. I tried to cover every aspect of the issue that I could. And so I've had debates with a couple of flat earthers, maybe 3 or 4, probably. I did have my first debate with Ron Skiba, who's now deceased. And he was the leader, I think, of the movement for a while there until he died. And that was in Denver when they had their Flat Earth conference. So I was invited out there, and I got to meet all the flat earthers, all the heavy hitters, and it was fun, actually. But I don't know what more to say. I've been at this for a while. I got my BA, MA, and PhD in theology, theological studies. So I don't know. I think I come equipped to debate the issue. At any rate, I'm here, ready to go.
And we're happy to have you here, Robert. Hard to believe you missed anything in that 750-page book. So that is definitely a comprehensive book, which is why I'm thrilled to have you, Robert, here, and then also Nathan, as I know you both have studied this topic intensely. Robert, you've got to meet all the heavyweights in the flat earth world at the Flat Earth Conference. So, okay, this should be interesting. This is going to be a lot of fun. I'm excited for this. And we're just going to kind of get right into it, Nathan. We are going to focus on each point one at a time. We've got about 5 main arguments with some scriptural references as well. So we'll make sure we have more than enough time to discuss each relevant point. Nathan, we'll start with point 1. And so we'll hand it to you. Take the time that you need to basically convey that argument. Then we'll hand it to Dr. Sungenis for a response. And then we'll jump into some easygoing back and forth discussion on point 1. So Nathan, whenever you're ready, the floor is yours. Go ahead.
Sounds wonderful. Thank you, Donnie. If I could, let me see, share my screen. And actually, real quick, I do first want to say, as far as I'm concerned, and people I've met, the flat Earth movement is really Robert's work, what he's done with the principle, is monumental to the flat Earth. This man causes havoc to the world, to the cosmology of what I believe is of the enemy and the worldview of the enemy. Robert is absolute havoc in the flesh towards that. And so flat earthers, we have a lot of respect for Robert and the centric work that you've done. I think I can speak for at least a few people. So that said, I will let's see, share my screen here. Let's see.
As you're sharing your screen, Nathan, just let me know when it pops up there. I'll let the audience know. Yes, as usual with these debates, we will be doing an audience Q&A. And so when we've exhausted the topic, we've discussed and engaged each of the important points tonight, we'll open it up for audience Q&A. So please, if you do have a question on the flat earth, make sure you're tagging me either at Donny or at Standing for Truth. And again, if you want to see more from our guests tonight, Robert and Nathan, do check the description box for their relevant links. Nathan, did you need help with the share screen?
It says Google Chrome may not be able to record the contents of your screen until it's quit. I might have to quit and then re-enter. Should I try that real quick? Should I hit quit and reopen?
Yes, if you haven't screen shared in StreamYard before, then it'll make you have to refresh everything. So if you leave the studio, come back in, you should be good.
Okay, let me hit this button real quick.
Okay. All right. Well, it's just me and you now, Dr. Sungenis. I can pretend to be the flat earther and debate you, but I don't know if I'm ready for that. So in the meantime, I will give a shout out to tomorrow night's debate. So we've got a few nights worth of main events. So tonight, of course, flat earth on trial. I have been excited for this ever since we set the debate. Tomorrow we'll be back for an eschatology debate. So we're mixing it up this week. This will be the Great Millennium Debate. Is the 1,000 years future? Pastor Anthony Aquino and Dr. Don Preston. And with that, Nathan is back. So we'll give your screen share another shot, and it should work.
Share. Do y'all see my screen here? Is this what we... Okay.
Yes, I see it.
Yes. Yeah. Looks good.
All right. So then I will go ahead and pull this up. Could y'all let me know once this is once y'all see the scenarios for planet Earth?
Sure.
If that pulls up.
Yeah, I just see your email currently.
Let me go escape and then wait, I think I have to click.
When you shared screen, did you share entire screen or just a single window?
Here, let me go present, share. Entire screen. Gotcha. Okay, share now. Got that. Okay. Now do you see is this slideshow set up?
Yes.
Okay. All right. So sorry about that. So this is a discussion about the shape of the earth, not necessarily its position in the universe. But being that we are both geocentric, we are discussing if the earth is planar or if it is curved. And so for the first topic, I think I can hit space bar. So the topics that are going to be covered here are going to be a four lights observation, bottom up disappearing, water reflections, and then Bible verses. And so the first topic here is the four lights observation. So there was someone who Grota1, Groutaone. He went to this lake and it's about 8 miles long. And so what he did was he set up a camera with an observer height of about 6 inches, and it was able to capture in a line. You can see these four specks of light on the right side of the screen, this right image. There is a red light, an orange light, a blue light, and a yellow light, and they are all 1 mile spaced apart at 5, 6, 7, and 8 miles respectively. And all of these lights are set up on a contraption that is 1 foot above the ground. So all of these lights are 1 foot high, and all of them are seen from an observer height of 6 inches. Now, if we look at this geometrically, mathematics can prove things. Science uses evidence and methodologies to kind of support ideas, hypotheses. In math and in logic, there are proofs. And so as a geometric proof, if we look at the side view of this 4-light experiment and the observed lights are plotted on an XY Cartesian coordinate grid, the shape of the graph shows a line because we view all 4 lights at 5, 6, 7, and 8 miles in a line from an observer height that is 6 inches, so actually below the lights, and it makes a straight parallel planar line when you draw a line to connect those points. And so we can conclude if water is planar over bodies of water at rest, then oceans and lakes and other bodies at rest are planar. And so physically, this cannot be a globe, because if all water is shown planar when we test our natural world, a globe contrarily claims that water is bent at a constant rate at around an oblate spheroid with an equator of 24,901 miles. So there are curvature equations that you can use to determine how much curve there would be. And using geometry, we can calculate the curve of the Earth would hide these lights, as there must be a physical drop to these lights from an observer looking tangential outward. So it is a mismatch of claim to reality. A globe has continuously curving water, as you can see on the left side. The water that is the oceans, if you look at the edges of the globe, those would be curving. So that would be definite physical curved water wrapping around the outside of this ball. And then if you look at kind of in the right middle of the screen, there is a curvature formula that you can do to calculate how much curve there would be at such a distance. And there are a few different ones, but they all are relatively close to one another in what they predict. And so you can see that both of these are showing that there would be physical curve, but all of these lights in our shared reality are actually resting in a line. And so demonstration, this 4 lights observation has yet to be recreated on a known curved surface scaled to globe proportions and show that any variable or natural condition can recreate this phenomena. The globe cannot show that it is possible to have these lights merely appear flat using controlled settings that may be offered as explanations, thus falsifying those experiments. So basically, a flat Earth, we see something that appears flat, as in these 4 lights at the bottom, and a flat Earth can recreate on a flat surface 4 things at similar height appearing or at the same height appearing in a line, whereas you cannot take a known curved surface and isolate for any variable, be it refraction or whatever you want to claim is causing the phenomena, and they cannot recreate a known curved surface giving an appearance of exactly flat planar lights. So that is about it for the first topic, and then I pivot into the second topic from here. So I will escape my screen and stop sharing. Are we back? Everything's back here?
Yes.
Yes.
Yeah.
I'm back.
Okay.
Nathan, thank you very much for point number 1. We're now going to hand it over to Robert Sungenis. The floor is yours.
Okay. All right. So, what I would attack first is I saw the whole video, and I saw the camera that you said was 6 inches above the ground. And I saw him measuring the height of the camera with his tape measure. Okay. And right away, I began to be suspicious of the accuracy of this experiment, because on a 8-mile surface maximum, 1 millimeter of the height of the camera that's different from one exposure to the next is going to greatly affect what you're going to be able to see in that 8-mile margin that he's created. So I felt right away that this was sort of mom and pop kind of measurements that he was taking that are not very accurate. And if there's any discrepancies, that this would be one of the things we would point to is it really 6 inches off the ground, or is it 6.1 millimeter inches or 6.1 inches off the ground, or 5.9 or whatever? Is it moving from side to side? Is it moving diagonally? What is the wind having any effect here? I'm not saying that it is. I'm just trying to look at all the angles here to see if this thing is as accurate as it purports to be. Okay, that's number one. When I looked at the picture and I took a snapshot of it myself, here is what it would look like on a black screen. And I measured the height of the lights from the red line that's down here, just to make a preliminary measurement. Okay. And the astounding thing that I found out was the light that was furthest away, the brown light over here. Okay. That was a little higher than the blue light and the red and yellow light. The red and yellow light and blue light were almost the same, but the brown light was higher, which shouldn't be the case. Okay. Because if let's just say you had a flat earth here, well, they should all be in the same plane and not one higher than the other. And I measured it again. I got the same result. Okay. And that's one problem, because you have to ask, well, why is the brown light, which should be lower, actually higher than the other lights that are closer to the camera? And, this is one instance of reverse refraction. If you're going to have cold temperatures when you're doing the experiment, as opposed to like Joshua Nowicki has when he photographs the Chicago skyline from the other side of the Lake Michigan, which is about 60 miles. Okay. He sees the Chicago skyline, but he shouldn't, because in 60 miles, the curvature of the earth should put the Chicago skyline down about 900 feet. Okay. Now, that is easily explained by refraction. As a matter of fact, you have computers out there now, and I've mentioned them in my book, that take refraction into account, and the results are phenomenal when you do not include refraction as opposed to including refraction. And you can plug these numbers into the computer and it'll calculate it all out for you. Okay. You can have reverse refraction if you're on a lake that's frozen and the air above it is now warm. Okay. You can have inversion with such great temperature changes. And as a matter of fact, the brown light here would tend to go up with the light, because the light is going to be concave at that point instead of the reverse, convex, as you would get on Lake Michigan when the air is warmer in the spring. Here you have coldness in Canada and it's staying cold, and so that light is going to be go the opposite direction. So that would explain why the brown spot is higher even in a confined area of 8 miles, because that's a lot less than what you see in Michigan, where you have a 60-mile difference from one end to the other in your experiment. Here you have only 8. So if you can see even a slight difference at 8 miles, well, something's got to be bending that light in the opposite direction. Okay. So, you're not going to see any curvature First of all, it's very hard to see curvature in 8 miles. The math is going to tell you one thing. What you actually see in reality is going to be something very different. Okay. And that's what they find in all these experiments. They try to make everything just right so that it all fits together and there's no anomalies, there's nothing that's going to mess things up. And it never turns out that way. There's always something that messes things up. And so to get a perfect experiment is very hard to do. Okay. So the math is easy. The math never makes a mistake. So that's easy to get. Trying to duplicate the math is another story altogether. Okay. Because math doesn't take into account refraction or any of the other anomalies that are going to occur in instances like this. So, I would say that this really doesn't prove anything. Okay. I would say that the margins are too small in order to get any kind of clear picture that the Earth is flat here. Okay. As a matter of fact, it's going the opposite way because the brown light's going up and the others are staying. And the other problem with these lights is you'll see here, see if I can get it closer. Like, just take the red light, for example. Where am I? Okay. You see in the red light, it's like when you're looking at an eclipse, you see this corona around the red light on the outside, and then you see the colors get a little deeper red here, and then in the inside you see this core that's almost like orange. Okay. So this is caused by light diffusion. You get the same thing with the blue. You see a patch of blue here at the bottom, and then you see another shade of blue here at the top, and you see a little corona on the outside. And the same thing with the yellow. You see a lot of yellow corona on the outside, and you see other deeper yellows in the inside. Okay. You don't see as much with the brown one because it's probably further away, but you're going to get all this light diffusion. So the question is, where are you going to make your measurement? You're going to make it in the center of the circle? You're going to make it on the outside, where the outside just is in line with the bottom here surface of the Earth? Okay, where are you going to make the measurement? So you have these big blobs to take care of, a little smaller blob, and then a much smaller blob over here. So where are we going to take the measurement to decide how high this is above the Earth? Okay, when I did that measurement, I took it of the lower side of this brown light here, okay, and I took it of the lower side of the red light here, and the brown light was higher than the red light. Okay, so that shouldn't be. And so I wonder about the accuracy of the experiment. What he needs to do if he wants to try to prove his case, or not necessarily prove it, but at least get a more definitive result that will not be so sketchy, is to do it about a dozen times. Okay. And I guarantee you, every time he does it, he's going to get a different result because the conditions are going to be different. The temperature is going to be different. The humidity is going to be different. The time of year is going to be different. A lot of factors are going to go into this. See, and this is what science is all about. You can't take one sample, one experiment, and then make conclusions of it. No scientist will ever allow you to do that. He will tell you, no, you need to go back to the drawing board, okay? Because nobody's going to accept just one experiment and you make a conclusion, well, the Earth is flat, okay? Can't be. If Joshua Nowicki had done that, and takes his pictures of the Chicago skyline in April Okay. And he can see the Chicago skyline, and that's all there was to it. Okay. Well, yeah, he'd be the most famous man in the world. Okay. But he's not. Why? Because if he takes the same pictures in September or October or December, he doesn't see the Chicago skyline. Why is that? Well, has the earth changed? No. If it's curved, it's curved. If it's flat, it's flat. What has changed? Well, all the stuff between Joshua's camera and the Chicago skyline. That's what's changed. Enough so that he can't see the skyline in December, but he can in April. Every April, he can see the Chicago skyline. Okay? So if he wants to prove a point, he's going to have to say, okay, I took the pictures in April, May, June, July, August, September, October, December, November, December, January, all the way to March. Okay, we got 12 samples now. Let's examine them all and see what occurred. And that's what this man would have to do in order to have any semblance of acceptance of his experiment to prove anything.
Dr. Sungenis, I appreciate your response to Nathan's point number one. To the audience, I am all caught up on questions. I appreciate how engaged everybody is in the live chat. Okay, Nathan, what we're going to do now is enter a bit of a discussion on topic number one. And so why don't we allow you to pick a specific point to go back and forth on? Go ahead.
Yeah. Can I first just ask, is anyone said anything, like, is my audio coming through okay? Like, I'm not scratchy or skippy or anything?
It's sounding good now. Yeah.
Okay. Okay. Yeah, so definitely we can go through. So I wrote a couple of things down here that you brought up. And so I could kind of maybe tie a couple of them together. If I could share my screen real quick. Let's see. Entire screen. Click there, share. Okay. All right, sweet. So I should have this pulled up. So if you can see here, this has to do with refraction. This is an equation for in a lab. When you calculate refraction, you essentially have a refractive index, and when you measure it, you can measure light traveling through a medium, and then how much the light bends or deviates is what your refractive index is. And when they measure these refractive indexes in a lab, they actually have a standard. So 20 degrees Celsius is the standard temperature. And for each degree above or below 20 degrees Celsius, what you would do is you would take that measurement. Say you measured 1.3337 for your refractive index. If you go at 20 degrees, if you go to 21 degrees, you would have to add onto that measurement 0.0004. Whereas if you went 1 degree below, you would subtract 0.0004. So if you had this 1.3337 measurement, what would happen is if you were 1 degree warmer, you would change what you would measure 1.3337, and then you would add 0.0004. So your refractive index in that 21 degrees Celsius measurement would be 1.3341. And if it was a cold, a 19 degrees Celsius measurement, you would subtract. And so that would be 1.3333. So what that essentially means is in warm temperatures, you would add to your refractive index. In cold temperatures, you would subtract. Now, what this would do in demonstration is it would say light is bending around the curve and bending down towards your eyes. If you are adding to that measurement, you are going to say bend the light more towards your eyes. But then if you subtract, it would have to be, it wouldn't bend down as much and go above your head. So they're conflicting. If you can say we see too far because of cold temperatures, we shouldn't be able to see in warmer temperatures because the temperature is bending the light the other direction. So instead of being cold enough to bend the light towards your eye, if it's too warm, it wouldn't be able to bend the light down far enough to meet your eye so you could see it. And so that we do see too far in both very cold temperatures and in moderately hot temperatures, that actually shows that there are multiple conditions where we can see too far, which would defy the way that refraction bends. And so within, so we get this bending of light with refraction in both temperatures. And then to say that, it's that 8 miles might be too small of a margin, the typical globe dimensions and the typical like ancient how we knew the earth was a globe sort of reporting was about let me see if I even have some. It was about ships going over the horizon and going over the curve of the earth. And so instead of going over the edge, they would go over the curve. And that is supposed to be at about 3 miles. You see the boat disappear. And so so this is supposed to be 3 miles. You can hide a 6-foot ship. And so this is actually the closest light in the 4 lights experiment or observation is actually further out. If you can hide 6 feet of 6 feet of boat at 3 miles, this light is 1 foot high and 2 miles further out, and that is to start. And all of these lights are incrementally spaced, and refraction is, and it's supposed to be an exponential curve. So this same refractive index or refractive variables, refractive conditions is bending equally spaced lights exponentially apart from one another. There's drastically more curve downward 8 miles away than at 5 miles away because it's got a curvature to it. And as you curve more, the last curve starts bending your direction further downward as opposed to further outward. So the official narrative for a globe is to be able to hide curve at 3 miles. Yes.
I was just wondering if you wanted to wrap it up soon, just so we could engage it as well in the form of discussion.
So too. Yeah, I'll start with those, and then we can, if you want to address that, and then we can get to the light diffusion, where to measure the multiple measurements, because I do agree science is about making multiple measurements. So yeah, if you want to go at the curvature rate of what we see disappearing, yeah, go for it.
Okay, we'll hand it over to Robert to address anything he'd like to based on what you just said. Nathan, go ahead, Dr. Sungenis.
Okay, so in my book, this is an older edition, it's page 525. It's probably 528 now. Anyway, I show these charts here. Oh, I hope you can see them. Whoops. Okay, so it's hard to figure out how to bend this on. Okay, well, here's a chart here, and that one, if you can see it, it shows 6 different refractive rates. I'm talking about the one at the bottom here. Okay, so they have no refraction, weak refraction, normal refraction, severe refraction, and then there's 2 other ones there. I can't even see the name of them. But they have different refractive rates that they will use. And you'll see at the bottom it says you can't see the object in these lesser refractive rates, but then to my left here, my left, or is that your right? I'm not sure. But right here, right, in green, it says you can see them. If the refractive rate is so severe, you can see them in 2 of these categories on the, did you say left?
Right.
Right. You're right. Okay. So the other 4, you can't see it because the refractive rate is not big enough. So what this tells us, and you can go put all these in the computer, by the way, and you'll get this kind of chart, and it will tell you the difference in what you can see, what you can't see.
Could I ask, are those strong measurements that allow us to be able to see, are those in cold temperature conditions, or are they in warm temperature conditions?
Well, the last one here says polar, so that's cold, I would assume.
Okay.
The other one says severe. The other one says intense, and that's where you can start to see the object. Okay. In severe and polar, you can't see the object because the refraction is that great. So what this tells us is there are many different refractive rates that come into play when we're doing an experiment. Which one we're dealing with at that point in time, at that experiment, who knows? Okay. So the other problem here that I see is that you showed the ship, and it's going beyond the horizon, and the ship is going down, and but that's not the same as you have in the light experiment. There is no horizon in the light experiment. What you have basically are just 4 lights in darkness. So you have this brown light that's supposed to be further away, but you can't tell whether that's going up and down when you because there's no horizon there to compare it to. The only thing you have to compare it to are the blue light, the red light, and the yellow light. Okay.
But
you
there is
can't
also
do it
beyond the light. The furthest light, there is more beyond that we can see further. So it's not actually at the horizon point. There is still more Earth beyond that light, whereas the physical geometric horizon should only be so far, especially with a low observer. The lower your observer height, the less far, like both models claim, the higher up in elevation, the further you can see. So if you go lower in elevation, the less you can see outwards. And so from a lower observer height, there's physically too much land outward to allow it that we can see, that geometrically should not be allowed by the curvature, the physical curvature rate of the globe plus the refraction it allows. We are still seeing what the refraction cannot bring up enough.
Well, that's an assumption you make. Proving that is what you have to do.
So,
okay. And
yes.
let me just continue, because I had another point on top of this one that was going to be my real point.
Yes.
So the point is not that you don't have a horizon. That just leads to the next point. The point is that you have 4 lights, and you are using the lights as the standard of measurement. Okay. You can't do that in an experiment. The lights are your variables, so you can't use them as the standard of judgment to judge whether light 1 should be lower than light 4, because you don't know where light 4 is. All you know is that you've put it so many inches above the ground. That's it.
You do know where the furthest light is, because he had it set at the very edge of the lake, and then he brought it back to like he used his odometer on his truck to get them roughly about 1 mile apart.
Oh, I know that. I know that
the distance of the furthest light.
Yeah, I'm not talking about the distance. I'm talking about whether that light's going to go up or down depending on your point of view. And the only thing you have to judge that, like, for example, the only thing you have to judge the brown light in the back is the other 3 lights. Okay? That's it. You don't have a measuring stick sticking out in the sky that allows you to measure how far the brown light has sunk or risen. You don't know. All you know is you have 4 lights. So the question is, can you use those 4 lights as the standard of measurement for the experiment you're trying to prove? And what I would say is you're using as proof the very thing you're trying to prove.
To that, I would say, if you take, like, because the claim of the globe is to claim to know the dimensions of the globe, so we know even how much the globe weighs supposedly, but they say that the globe has an equator of 24,901 miles. And so if you take a circle of that equator and then put it on a piece of paper, you can calculate how much curve there would be at each.
I know all that, Nathan. You don't have to go through that. Okay.
So
I know all that.
you are
what I'm
8
saying
miles
is
away,
you don't know what other factors are involved in this situation that's going to cause a anomaly in the math result. Okay.
Yes. So you if you know the light is 8 miles away, you can do 8 inches times 8 miles squared. And then you will get how many feet drop that would be as a rough
I understand that.
approximation.
I understand that.
And so, and then you have the refraction of that, but you can make these long observations. If it takes extremely cold temperatures to cause light that's that far down to bend up to our eye so that we can see it that far away, and refraction would allow these globe defying observations to be made, then we also should not be able to see too far when it is warmer temperatures if cold air is what is required to bend the light down.
No, the cold air is bending it in the opposite way than the warm light, than the warm air would.
Yes, okay. And but that's the thing, is that we see too far in both conditions of cold and warm light or warm air. We are still able to see things which physically and geometrically defy what the globe is allowed to permit.
But you don't know that, because the video that we saw said nothing about refraction, not a word. So that means he didn't even take it into account. All he did was take the parabola formula that you just used, okay, x equals 8y squared, and he said this is what we have to see. And there was nothing in the video that says, well, what if we don't see that?
Yeah, I'm just talking about the observation that we make of the natural world.
I know that, but see, that's what Joshua in the wiki said too.
And so you
know which one I'm talking about? The Joshua,
the Chicago across the Superior Lake.
Okay,
the Great Lake.
So I mean, I'm going to use that as my standard, because he admits he can't see the Chicago skyline in December, only in April and May.
And a flat Earth, actually, contrary to the globe, flat Earth says on clear days with clear conditions, you can see further, which allows these things, these long sightings. But if you have certain conditions where maybe there's fog or haze or more water vapor in the air, more humidity, that actually limits how far you can see due to magnification and things like that with the water vapor.
You can see 27 miles on an exceptionally clear day, and whereas you can only see about maybe 10 feet in front of you if it's very foggy. But see, the point is, he takes pictures of the Chicago skyline in December when it is a clear day, okay, and he still can't see it, okay.
The conditions do have to be right: temperature, debris in the air, water vapor, humidity. There are many factors, but what I'm saying is
determine that it is a clear day. There's no humidity to worry about, no fog, no nothing to worry about. It's the clearest day you can have. They've taken pictures from Michigan and still can't see the Chicago skyline.
That would mean that some variables are not there to allow us to see that far. But the thing is that if you take any of these conditions, if you say it's temperature, it's what's in the air, it's the water vapor, the refractive index, if you take any of these conditions that you want to isolate or use them all together, and you're using realistic temperatures like 20 degrees below zero up to 120 degrees, you're not going super cold. That's unrealistic to temperatures we experience out there. A globe cannot take a known curved surface and isolate any of those conditions and apply them to a setting where you have the scaled recreation and show that any of those variables can bail out this observation and show that a known curved surface can make an apparent flat looking line. With the lights, the blur and everything, I would think that would have to do somewhat with refraction or water vapor things. But they appear roughly straight, and measuring, if I was going to measure like height from above the lake, I probably would measure the center of the brown light and then the brightest spot of the blue light, and compare heights. But they are roughly linear, as opposed to like if you put a 6-foot boat out there at 3 miles, it's going to be down below the horizon. But we're seeing a 1-foot light at 5 miles, 6, 7, and 8 all in a line. But there's a curve gets steeper the further out you go. So that last light would be like here, whereas this one here would be here, 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 and get closer. But that, I think, would be, to me, that we see too far in cold or hot, because those refractive indexes need certain temperatures.
Let me ask you one more question, and then maybe we can go on to the next topic.
Yes. Yeah, absolutely.
And that is, do you know anything about Michigan? You know, like where certain cities are, and
kinda.
Okay, so Where Joshua was right on the shoreline of Michigan.
Yeah, the West
and
Coast.
It was like the southern part of Lake Michigan. And so at that point, you know, it's like 50 to 60 miles to the Chicago skyline. Let's say that Joshua went to Lansing, Michigan. Lansing, Michigan is about 110 miles from the Chicago skyline, and it's due northwest of where Joshua was when he took his other pictures. Okay. So northwest, and then you measure from Lansing all the way to Chicago, and you get about 110 miles. All right. So if the earth was flat, Joshua should, and Joshua took his camera there in the best of conditions, okay, where minimal refraction, minimal humidity, just beautiful temperature, beautiful day, and he took his picture. Should he not be able to see with a P900 camera or even with a telescope? Should he not be able to see the Chicago skyline from Lansing, Michigan?
No, I don't believe so, because if you are looking over that vast of a distance, there will be things that will get in your way. We can only resolve so much angular resolution. We see in angular, everything is apparent to our perspective. And so we can only resolve things at such a small resolution.
All right, let's say we
Otherwise,
had a really good telescope.
But even
one telescope that we can point to the moon and see craters on the moon. You think that's
because you can with a P900, you can zoom in on the moon with a P900 and get very close to it, exceptionally close. But on Earth, if you look up, you're looking through what would become thinner and thinner atmosphere, less water vapor, less medium change, thinner medium. And so when you're looking through a over water, especially if it's going to be like a warmer day where there's water vapor, you're going to have water vapor, which magnifies. And so if you magnify an object, it's going to become bigger in your field of view. So other things around it are going to be crowded out because that magnification has to take up more space and make it appear bigger. And so the water is going to magnify things. And over those long distances, you won't be able to see after a certain point, because it's all essentially like magnified out. Everything is beyond the vanishing point of our horizon, because ground and sky compete at the horizon line for informational data that your eye can receive the light from. So everything above goes down and everything down goes up to our horizon. And there is a hard cutoff point where we could only see so far. If you're at a high enough elevation, you could see far enough. But both models can claim that. But yeah, I don't think we have like a zoom capability or anything like that would allow it. But I think there are atmospheric conditions. As they stack up, you start to look through like an inch worth of water vapor, and then maybe 2, 3, 4, 5 inches of water vapor, or of what would be total water, liquid water over all that distance. That will kind of muddy your vision a little bit so that you can't see and resolve those very distant objects.
So after I'm listening to you saying all this, I think you're on my side more than you're on your side, because you're talking about all these obstacles that come in your way.
The Bible's amazing.
When you're trying to prove something that the earth is flat. Okay, so these are the exact same things I was suggesting to you. All these things get in the way. Those were your exact words. These things get in the way.
At extreme distances, they do, but at close distances, the globe is claimed at 3 miles, a boat disappears, and that's how the Greeks knew that the earth was curved back then, was they watched a ship disappear bottom up at 3 miles. And I could transition into my second point, because the second point is bottom up disappearance.
Yeah,
okay, let's do this, Nathan. I'll jump in. I'm going to give Robert the last word for this round because you started, Nathan. So, Robert, go ahead with a final point, and then we'll throw back to Nathan for argument.
I mean, thank you, Donnie. If I were a flat earther and I wanted to convince somebody of the flat earth, first thing I would do is go to Lansing, Michigan with my super duper camera, try to take a picture of the Chicago skyline. And if I could, I'd say, guys, I just proved the earth was flat. You know, because I'm twice the distance that Joshua Nowicki was. And if the earth is curved, I really shouldn't be able to see the Chicago skyline from Lansing, Michigan. It should be 1,500 feet under the horizon. Okay. But if I can show, now, I don't know why all the flat earthers aren't rushing to Lansing, Michigan, or, Kellogg, Michigan, or wherever to try to take a picture of the Chicago skyline. I just don't know why they're not rushing there, because that would be the first place I would go. You see? Now, if you're right that all these other things get in the way, okay, so I'll wait for another day and take another picture. I'll take it for 365 days out of the year if I have to, because if I can prove the earth is flat by one picture of the Chicago skyline from Lansing, Michigan, I just became the most famous guy in the world. Okay? That's all I'm going to say.
All right, fair enough.
Okay, gentlemen. Great first round. Very engaging. I'm enjoying it. Okay, so Nathan, we're going to throw it over to you now. Topic number 2, and if I'm not mistaken, has to do with observations along train tracks in Canada. So I know a thing or two about Canada. I'm Canadian. So, okay.
Yeah.
Nathan, over to you. Floor is yours.
So actually, I was going to bring up an observation that was made along the railroad tracks in Canada. But the original poster of this observation, they took their video down. So I'm actually that was going to go with something about being able to see too far over land. I'm not going to address it because I can't cite the original video because the observation is taken down. So I actually was going to transition right into the next point of bottom up disappearance, as opposed to the railroad sighting, just because I can't source the original. Is that okay?
Yeah, it's okay with me because I didn't go over the railroad track thing. So.
Okay. All right.
Works for me as well, Nathan. You're
okay.
good to go.
Sounds good. Then I will share screen again here and go to, is my screen showing the demonstration pivot?
Yes.
Okay. So the pivot is demonstrations of isolated variables that can be found in natural conditions can be used to show what we see in our world scaled on a known flat surface. So basically what that means is bottom up disappearing is something that gets brought up in this topic. So observation, bottom up disappearing of an object at a distance. So this is an example of the Toronto skyline showing buildings that are below what looks like below the curve of the earth, below the water, and you can see only the top portions of the buildings. So to legitimately look at an explanation for a flat earth about if the flat earth could be viable, a flat earth has to explain, how can we see this? How could we see bottom up disappearance on a flat surface? So the flat earth explanation, the water and the air are above, the water and the air above are at different temperatures. This causes a temperature variance and gradient. This changing of temperature causes refraction, zoom due to water vapor, lens magnification, etc. i.e., if there is a change in temperature above the air, what you see will change. So question is, can this be shown on a known flat surface using isolated realistic variables and provide a demonstrable showing of bottom-up disappearance on this known flat surface, showing that it is possible to have bottom-up disappearing on a known flat surface? So what I have here, and I will play it, this here is going to be what we have. Oh, whoops. So this is a bunch of objects on a flat surface. It's like a bread tag, a couple of push pins. So it's a scaled recreation. You can see the bottoms of everything. And then what is going to happen is cold air is going to be let into the room. And then what you are going to see on this flat surface with all of the bottoms showing in these low objects is suddenly now with a realistic condition like changing temperature, you actually do get a bottom up disappearing of everything that we see. And so you can only see the tops of this here, which does match down here what we see, along with up here on certain conditions, you can see entirely across and see the bottoms of buildings. But sometimes there are conditions depending on temperatures and things, as we've discussed, which can hide those. But the flat earth can, on a flat surface, show it is possible to hide the bottom of these objects here. These are all visible, but if you change this one variable, you suddenly get a hiding and only see the tops. Implication of our recreation observation: we can recreate on a known flat surface using conditions and temperatures equating to what we experience when making real-world observations, like, say, 60-degree temperatures or 70-degree temperatures, and show bottom-up disappearing objects. This falsifies the claim that bottom-up disappearing of an object is only explainable on a curving Earth. So not that the globe cannot explain bottom-up disappearance, but a flat Earth also can explain bottom-up disappearance. And so here is seeing bottom-up disappearance and too far away. This is a picture of very distant mountains, which should have their peaks hidden by miles of curvature, but we can see the range. This is from an elevation, but this is one example of seeing extra far. And so I will, where did my mouse go? Escape, maybe? Stop sharing. Okay. So, yeah, Robert, if you want to respond to bottom up disappearing.
Okay, Nathan.
So the
thank
first,
you. Robert will throw it back to you. No worries. I was just going to say, okay, Nathan, thank you for point 2. Robert, we're going to hand it over to you for your response. The floor is yours.
Okay, so the first thing I would say is that this doesn't prove anything for the flat Earth side of the story. I think Donnie's or Nathan's already admitted that. So I'm puzzled why he chose this out of all the supposed proofs for flat Earth, that he chose this one to demonstrate, because it doesn't prove the flat Earth. All it does is prove that the flat Earth can match the explanation of the curved Earth for bottom up for bottom building disappearance. Okay, but that means we're neutral. Okay, I'm waiting to sink my teeth into some proofs that you have that the Earth is flat. Okay, I haven't seen any, and this second one is not going to do it. So that's just the first comment I want to make. Second comment would be, if you believe in the flat Earth and you are looking at the Chicago skyline, either from Michigan or somewhere on Lake Michigan, let's say you're on a boat in Lake Michigan and you're 30 miles out from Chicago, and the Earth is flat, you should be able to see the whole skyline if the Earth is flat on a good day. Okay, on a good day. So I find it quite ironic that you're going to use the same kind of explanation I'm going to use to explain why we can see the Chicago skyline, when in fact, if the Earth was curved, it should be 900 feet under the horizon and should not be seen. That now you're going to use the same, because the reason I say that is because when we use that scientific data of air refraction, depending on temperature, to explain why those buildings can be seen on a curved Earth, we got a lot of flack from the flat earthers. Oh, yeah, well, you're just saying the Earth is, the air is warm, so you can, say the light is bent, and that's why it comes up, But come on, man. Come on. You have to come up 900 feet, and that's going to explain why you can see those buildings. So we got a lot of flack for using air refraction. Okay. And now I see that you're using air refraction to explain why you can't see the bottoms of the buildings, when on any normal day, if you're 30 miles out from the Chicago skyline and it's a normal day, you should be able to see the whole thing. What's going to stop you from seeing the whole Chicago skyline if the Earth is flat? Because the reason I picked 30 miles is because that's sort of the limit. Like if you're on the beach and you look out How far can you look out before the horizon's going to start blocking things? Well, that's about 30 miles max, even on a good day. Okay, so that's why I picked 30 miles here, because that's sort of the max for us. Well, it's the max for you too, in a way, because at 30 miles you should be able to see the Chicago skyline, the whole thing. All right. So the question is, I would ask also is, are there days that you could go out to the, say, on the Michigan shore, and you as a flat earther look at the Chicago, look towards Chicago? How many days are you going to be able to see the Chicago skyline, even with the bottoms taken out of those buildings? How many days is that possible for you? Have you guys actually done experiments on each month of the year and taken pictures of the Chicago skyline to see exactly what you can see? Have you done that? Okay. And if you do see the bottoms taken out of these buildings, when is that? What part of the year is that? Is that the same time that we, the curved earthers, say that you can see the Chicago skyline around April, May because of the temperature differences? Okay. So do your bottoms come out of your building around April, May, same as ours? Well, sounds like we're talking about the same phenomena. We just have two different interpretations of it. Okay. So again, that's not going to prove anything for you. And so I have nothing to say, nothing more to say on that one.
Okay. I do think why that was shown with the bottom up disappearance is why we here, let me go to present share screen. Why we see as far as we do. Wait, let's see. Hold on one sec. Present share screen entire. So why I showed that was because the reason why we can only see so far is because of the conditions of the air. And so if you do get it, like the temperature of the air and the temperature of the water, if you're on the lake, there's going to be a change in temperature, which is going to do what was shown in that example. Was if you have a temperature difference, it causes that bottom up disappearance. And if it's more extreme, then you're not even going to see anything at all, which is a lot of the time we don't see that far. The natural conditions put us in kind of a smaller sphere of visibility. And on certain days when the conditions are better, we see further out. But why we can see further down or further above. Donnie, can I share my screen for a sec?
Yes.
Is that?
I see your screen shared at the bottom, but I don't see any slides.
Is it is my screen showing right now? There we go. Okay. You had said that 30 miles was about the limit, but this is the Chicago skyline, that the Chicago picture that we have been talking about is this right here. This is a long distance sighting. So the flat earth can explain why we can see this far of a distance, but also show and recreate and explain why there might be some times where there are conditions where we can only see the bottom of the buildings or the very tops of the tallest buildings, or see nothing at all, and why it appears like we just look out and see water, is because of the conditions.
All right. So let me just stop you there, because we need to go on to other topics here. I'm going to say this. You can't just claim conditions. You have to show how the conditions are going to affect your line of sight. Okay. You keep throwing conditions out. Like, if the conditions are this, and that, yeah, but show us. Okay. Show us, prove to us that these conditions will inhibit, I'm not talking about a cloudy, foggy day. I'm talking about other conditions that only allow you to see half the building instead of 3/4 of the building.
Well, that's what I showed. I showed one example of one variable that does, in and of that one variable alone, temperature, that is able to obfuscate half the buildings, could obfuscate all of it. And that's just one condition, not including refraction or magnification or humidity. So there are other things involved that could compound with it, but just one example alone is enough to meet those requirements of
Yeah.
showing.
So in other words, there are so many variables that you really can't prove that the Earth is flat.
But a flat Earth can recreate in demonstrations using these conditions things that we observe in the natural world, as opposed to.
I don't understand what that means, Nathan. What did you just say?
Okay, so like if we see an observation that shows a flat Earth, and then we recreate that on a flat surface, we can recreate it using, and we say we're saying it's temperature while we see that far and it looks flat. We can recreate that on a flat surface. But what a globe cannot do is if we see something on, if we're flat Earth and we see something that looks globe, we can recreate on a flat surface using realistic conditions to cause it to look globe, like for example with bottom-up disappearance, as I showed in my slide, was bottom-up disappearance on a known flat surface. What a globe cannot do is, say we make an observation that looks globe, and a globe can take a known curved surface and say, yeah, we can show this, why we would only see the top of this building. It's, the curve is like this and the building top is sticking up like that, so it's a little over the horizon, and so we see the top of the building. But what a globe cannot do is, if something looks flat, a globe cannot recreate on a known curved surface that appearance of looking flat using whatever variables that you would like to.
Okay, so I would say, so what?
Okay. So recreatability, repeatability.
Nathan, I just want to make sure Robert can finish his thoughts. Yeah. Go ahead, Robert.
My objective is not to recreate it in my laboratory, okay, because that's almost impossible to do. It's not to recreate it on my desktop. Yeah, you have an easy time because your desktop is flat. It's not curved. Okay.
Yeah, true.
But not only will you have to get a globe, you're going to have to get air conditions, temperature changes, all those variables that you mentioned. You're going to have to be able to include all those. Can you even do that on your desktop surface? No. Okay. Well, so why are you faulting me because I can't recreate it on a desktop surface?
That's part of with it, like science. I like my position on science is that like you make an observation and then you can set up conditions, methodology, your approach to doing something, and how you would run a test or run a demonstration. And then you would hand those conditions, methodologies to somebody else, and they could repeat those steps and get the same results. And so it's repeatability. So we can repeat realistic observations of our shared reality on a flat surface, but a globe cannot do the same on a curved surface.
Yeah, I know. You're just repeating yourself. So we know that already. Okay. Yeah. Let me pose this to you. Do you know about the Michelson-Morley experiment? I would assume, correct?
Yes.
Okay. You know how that all works with the light interference and how
they split the light and what the measurements they got were.
Okay. Yeah. So, what were let me ask you this. Was there just one interpretation of that basically desktop experiment, or were there more than one?
More than one.
Okay. So see where we are?
Yes, we agree. There's observation. Each side of whatever your claim is, each side observes what the data is, but then it's how you interpret it and how you explain it. But then it should also be what substance and context can you add to your explanations and interpretations that can support your explanation over somebody else's that has a different opinion of how to explain.
Well, I would say this, that just because you can put it on a desktop does not prove it, does not add anything more to your experiment to sound convincing to me. Okay. So you want to go on to the next one?
Gentlemen, I'll jump in real quick. Okay. So next one, correct me if I'm wrong, Nathan, water reflection. And then our last point will be Bible verses. So let's hand it back to you, Nathan. Point 4, water reflection. The floor is yours.
All righty. I will share screen here.
Yeah, just let me know when you're ready to go.
Yep, you can. If you could throw me up there on the screen. Let's see, play. Okay, so Water reflections. Water reflects images, flipping them over the x-axis and creating a 180-degree inverted image. So like this here, you can see the bridge is flipped over, the buildings are flipped over, the clouds. It's a mirror image. And reflections of planar and convex mirrors. So basically, if you look at the reflections of planar mirrors, or flat mirrors, like if you have one in your bathroom or something, like it's a flat mirror and it creates an image that is inverted to the original image, but the shapes, the proportions, the lines, the contours are a match, just mirrored, as opposed to, say, like a convex surface where you can see there is curvature, there is distortion, the way that the lights bend and straight lines bend. And so you don't get like a perfect mirror image of the on a convex. And so if you look at a comparison of which side compares most similarly to the middle, you can see that the reality picture is showing things are a direct flip. They're scaled proportionally, or they're equal proportions. They would match if you flipped them one on top of the other. The spaces between the skies or between the bridge pillars, the arches, the buildings is all equal, as opposed to seeing any sort of convexity that curved water surfaces would show. They would kind of create a non-reality in their reflection if it was convex. The buildings would curve. The way they appear in the water would be bent and distorted, as opposed to what we see above the water. So yeah, I'll just go there. And that should be about it for water reflection. Let me escape this and stop sharing. And yeah.
Over to you, Dr.
Okay.
Sungenis.
Could you put your London Bridge back up there again?
Yeah, for sure. Let's see. Screen share. Boom, bang, there. And Donnie, you're good to throw it up there?
Yes, you're good.
Okay.
Okay. So how long is the London Bridge? Do you know?
No, I do not.
Okay. You should have figured that out first. Okay. How long is the reflection from, say, point where that cone is on the left up top there to the point in the water? How far is that?
That I do not know as well.
Okay. So, do you know any of the dimensions that are in this photograph?
No, I do not.
Okay. All right. So, this picture is not going to demonstrate what you want it to demonstrate. Why? Because the margins are too small. Okay, it's a similar problem that you had with the 4 lights. 8-mile margin is not going to do it for you. Okay, if you use an 8-mile margin, you're going to have to do that experiment 50 times to make sure you got it right. Here, you're even less than 8 miles. You're not even You're not even maybe 300 feet in the air, and you have a reflection. If it's hard to see a curvature at 8 miles, okay, it's going to be a lot harder to see it here when you have a 300 foot reflection. Okay, so I don't know why you use this example. The principle that you're trying to show, I agree with, that if the earth is curved, somehow this image in the water over the proper distance is going to be distorted. I understand that. Okay. But see, on the right-hand side here, you use this, whatever it is, under the, what is that thing there? It says convex on the bottom.
It's like a mirror, like in a parking lot.
Oh, okay. So that's how many inches long?
I would not have the measurements.
Okay, so it looks like maybe 6 inches, 9 inches, I don't know, something like that. But you have this severe curve in there, in this 9-inch dimension. All right. So obviously you're going to see images distorted because the ratio of curvature to distance is so great, as opposed to what you're expecting to see at the London Bridge in the water here. You're not going to see that margin of curvature at all, nothing close to it. Okay. So this
Yeah, I do agree with you entirely about the scales are not equally represented. So yeah, I do completely agree that the it's not the greatest span of distance to allow for enough curvature to distort the London Bridge. It was more kind of principle, like the London or the salt flats. There are
yeah.
like salt flats around the world. Those as well are places where areas of land where you can go, and if it rains like a half an inch or something there, and then the rain stops, people will go there, and you can see mirror images that are directly flipped, but it's over a vast distance.
Well,
But
it depends on what the vast distance is. Even if it's a mile or two, it's not vast enough. Okay.
yeah,
The earth is big. Okay. So you're going to need some big demonstrations to be able to prove your point about this curvature business. So, they tried it with the Pontchartrain bridge in Louisiana. They've tried it with many other places. And I show this in my book. And they put the cameras in the wrong place. They assume certain things about the height and all that stuff. And it's in my book. And I would implore you, if you haven't read any critiques on those, that I'll send you a free copy of the book that
okay,
you can read them yourself. And when I saw them, Nathan, I said to myself, oh my gosh. I mean, I just see how easy it is for the wool to be pulled over our eyes if we just concentrate on certain things and leave out all the other things that mitigate that interpretation that we have suddenly come to. So yeah, I mean, that's why I put
yeah.
so much work into it.
Okay, and I do agree that the scale is not quite enough to show curve, but as part of like a preponderance of evidence, I think that this does show in support of like a planar mirror, because these observations that we make are so close that it would be apparent planar. And I do think that the water reflections do lend towards a planar explanation of water reflection, as opposed to a convex, because the scale is going to essentially keep everything boxed into it.
Okay.
Just
All
looks
right.
plain. But
Okay.
but I do agree that to scale, because it is important to keep things in scale and proportional, so that it's most accurately representing either side or either model.
Okay.
I 100% agree.
Okay, great. So I guess we're ready to go on, Donnie, to the Bible verses.
Okay, very
Yes.
good, gentlemen. Excellent back and forth discussion and debate so far. I'm really enjoying it. I'm learning a ton on this topic, and so is the audience. So, okay, topic number 5, Bible verses. So this should be interesting. Nathan, we'll throw it back to you whenever you're ready. The floor is
All
yours.
right. I'm good to share?
Yes, you're good to share.
Okay. Let me play this here, and then let's see, convergence. This is just my present. Yeah. Okay. So anyway, and this is actually I do think one of the most important topics, or the most important things of the flat Earth, is the near immediate biblical implications of what a flat Earth means in terms of Bible. So this is actually something, particularly the science and observations in reality of the physical world is one thing, but spiritually, this is like the most pressing. And so, how does the Bible describe the Earth? The Bible does speak about the immovability of the Earth. How about mention of the shape and form? And so the 5 particular verses here that are books that I'll be citing are Isaiah, Job, 1 Samuel, Acts, and Revelation. So the first one that I have here is Isaiah 40:22 paired with 22:18. So Isaiah 40:22, 40:22. This is from the King James Version. I particularly use the KJV a lot. I think you can get meaning from other versions, but I think that the KJV is rather specific. I don't worship any one version, but like, so anyway, I just chose the KJV. But what it says is, it is he that sitteth upon the circle of the earth, and the inhabitants thereof are as grasshoppers, that stretcheth out the heavens as a curtain, and spreadeth them out as a tent to dwell in. The other verse that I have coupled with this is Isaiah 22:18. He will surely violently turn and toss thee like a ball into a large country. There shalt thou die, and there the chariots of thy glory shall be in the shame of thy Lord's house. So in Isaiah, he says how our loving Lord sits above the circle of the earth, despite knowing the word ball, as he used earlier in his book. Isaiah uses the word circle to describe the shape of the earth. Circles are 2D as to 3D spheres, also mentioning a tent spread over the earth like the dome firmament from Genesis 1. So Isaiah knew the word ball, and I believe in the King James Version the word ball is used very sparingly, maybe one or two other times, but he knew what a ball was. But when he talked about and described the earth, he does call it a circle with a tent over it. And so if you look at like the first picture on the bottom left, there is kind of like an idea of what a flat earth would look like. And so you can see that it is a circle. And then you have the picture right next to it is a tent, which has a circular base, but a tent that is spread over it, which would kind of be the dome, the firmament, which is kind of that third picture in the center of the screen. It's kind of like a dome structure. And if you look at the far right image, you can see that you have kind of the earth with a dome around it, as ancient Hebrews believed. The people of the time were ancient civilizations were very flat earth. And so above the center of the firmament, you actually do have heaven as well. So it's a very local heaven, very, very close to the flat earth cosmology. And so he called the earth a circle with a tent, and he knew the word ball, but used circle. Next, we have Job 38:14. And so Job 38:14 says, it is turned as clay to the seal, and they stand as a garment. So Job talks about how the earth is turned like clay being...
Can I interrupt here for a second?
Yes.
Can we just go through one verse at a time, Donnie?
Sure. Yeah.
Yeah.
I think that's a good idea. Why don't we do the verses you've touched on now, Nathan? So we'll hand it to Robert. You get an uninterrupted response, and then we'll throw it back to Nathan.
Okay. So if you want to put those back up there, Donnie, okay, Nathan, thank you.
Yes.
All right. So let's look at Isaiah 40:22 first. Okay. Now, let's look at the context first. And the context is, it is he that sitteth, that would be God, upon the circle of the earth. How far up is he? Well, the inhabitants thereof are as grasshoppers, that stretched out the heavens as a curtain, and spreadeth them out as a tent to dwell in. Okay, so God's up in the heavens. He's watching the earth. The inhabitants are as big as grasshoppers. And if you take how big a grasshopper is, it's about 1/16,000th of the size of a typical human. Okay, so if you were to multiply 16,000 times, you get about 400 million miles, let's say. Now, this is just an odd calculation. I'm not saying this is what we're supposed to do. I'm just trying to show the context is God's sitting up high, and he's looking down on the earth. What's he going to see? He's going to see a circle. Okay, just like when you look at the sun, what do you see? You see a circle. When you look at the moon, what do you see? You see a circle. You don't even see a disc when you look at the moon. You see, all you see is a circle. So when God's looking up from far above and he looks down at the earth, all he's going to see is a circle. He's not going to see the third dimension. He's not going to see a disc. He's not going to see a cylinder. He's not going to see a sphere. He's just going to see a circle. Okay? So from that vantage point that Isaiah gives us, that God is as high as it takes to see the humans as grasshoppers, well, that's all he's going to see. Now, this is the Hebrew word kug. And kug is a common word, can be used as circle. It can also be used, as it is in Job 22, to represent the heavens. It's used of the heavens. Okay. Now they're not a circle. When we look up into the heavens, we see that it's probably a hemisphere that we see, but it's not a circle. So this word means more than just circle when it's used in Hebrew. The other thing that we need to know is, what is a circle? Well, a circle is a dimensionless figure. If I drew a circle on a piece of paper, it has 2 dimensions, not 3. If I want to go and for the 3rd dimension, I want to measure the thickness of the ink that I just put on the paper. Okay, you could say it has 3 dimensions, but a circle basically has 2 dimensions in common parlance. Okay, so it's not saying that it's a disc, and it's not saying it's a sphere. Why? Because Isaiah 40:22 is not arguing on the 3 dimensions of the earth. It's just arguing what God sees from his supreme height above. He sees a circle. That's it. Okay? So that's number 1. In other words, this verse doesn't prove anything for anybody except the shape of a circle. All right? Now, number 2 is Isaiah 22:18. I will toss you like a ball into a large country. Now, this is the word door in Hebrew. And it's actually a compound word because the English is like a ball. So it's kador in the Hebrew. So I'll throw you like a kador. I will throw you kador into a large country. Okay. Now, is kador a ball? No. It says like a ball. Okay. So we don't know if it's a ball. It's something like a ball. When you go and you look at the etymology of door and kador, what you see is it refers to anything that can roll. Anything that can roll. So that can be a ring, a cylinder, a hexagon, because they can roll. Anything that has a round shape is going to be able to roll, okay? Or something that where it has a circumference that is not going to be impeded by the earth or anything else. If it can roll, then it's kador, okay? So how many other words did Hebrew have for this kind of phenomenon? Well, it actually had 5 different words. And I can give you all of them. Just trust me that it has 5 words for something that's round shape, something that's curved, something. But here's the funny thing, is that Hebrew did not have a word for sphere. Okay. That might seem odd, but it did not have a word for sphere. So when it had to talk about shapes, it would use different words in different places, but you couldn't pin it down and say, oh, that's referring to a sphere or that's referring to a disc, because their words were just too general in order to pin it down and make a conclusion that, oh, this verse is definitely talking about a flat earth. Okay. In other words, Isaiah 40:22 proves too much for the flat earthers, because a circle is not a disc. They want it to be a disc, but it can't be. A circle is an abstract shape, basically, with just 2 dimensions. So it doesn't prove anything for anybody. All right, that's all I'll say about those things.
Could I respond to that?
Sure.
Sticking to the okay. Circle, I think abstract. I mean, I think like we know like circles are like geometric shapes, and so it's something that can describe like the appearance of something that is circular. I don't know, maybe that's defining with the definition or with the word itself, but like you mentioned, that is it kug is the Hebrew word for circle. So, and it could also mean like heavens. So then the verse would be, it is he that sitteth upon the heavens of the earth. So
No,
even
no, no.
in like it.
No, you got that wrong. So let me read the verse to you. And I didn't mean to take up your time because we're not keeping time.
No, you're good. You're good.
Okay. In Job 22:14, it says this: Is not God high in the heavens? See the highest stars, how lofty they are. Therefore you say, what does God know? Can he judge through the deep darkness? Thick clouds enwrap him so that he does not see, and he walks on the vault of heaven. Now that's from the RSV, Revised Standard Version. The word vault there is the word kug. Okay. So he walks on the kug of heaven. Now,
if he's sitting on the vault or sits upon the vault of heaven, in a flat Earth cosmology, above us is the firmament, and it's like a physical object that you could have heaven above and be on, and he could sit above it with the flat Earth cosmology interpretation.
Yeah, but it's not a circle. At most,
but a flat Earth or a globe could look like a circle from how, like if you view a flat Earth from above, it would look like a circle. If you view a globe from any angle, it looks like a circle.
That's exactly what I'm saying. That's why I'm saying
God
you can't use it to prove that the Earth is flat.
Well, is God is sitting above the Earth, so he's above our heads?
Yes, of course.
But then to someone in China, he's beneath their feet.
Well, it doesn't get into that issue. It's just saying that God's above in the heavens and looks upon men as grasshoppers. That's all it says.
So what if someone in America and someone in Australia, they're antipodal to one another, 180 degrees opposite on a globe? If they're both reading the Bible, God is above them both at the same time?
Well, the verse doesn't get into these issues. You're creating a straw man so that you can, go attack it, but that's not what the verse is talking about. The verse is just saying men look like grasshoppers to God who's in the heavens, and the earth looks like a circle.
Yeah. And to touch on that grasshopper thing, I think you threw out like 400 million, roughly speaking, miles.
Yeah.
Or, but I would like, I'm 6 feet, so my eyes are maybe 5'8" for 5'9", maybe off the ground. But like if I look down, I can see a grasshopper pretty clearly, like an adult grasshopper. I can see it on the ground. And so to me, like if God was sitting above a flat Earth, so I don't know, 300, 400, or 3,000 miles up, I think he would be able to see us looking relatively small, considering when we're like in an airplane, we look down and we can't see anybody, and we're only a couple thousand feet in the 35,000 feet in the air. So I think that the grasshopper thing as well could work. The tent, I don't know about outer space, like looking like a tent. How do you figure that? Like, is outer space a tent or a ubiquitous three-dimensional?
I really don't want to get into those issues right now. All I wanted to say is that you can't use circle in Isaiah 40:22 to prove that the earth is flat. That's all I wanted to say.
Okay. Do you want to get into the Isaiah 22:18? Because I did write a couple things down with that.
Yeah, feel free to rebut whatever I said.
Okay. So with 22, because I know in the email, I'm sorry I didn't say this 22:18 portion. I was kind of using it to support. But yeah, when you say that,
I knew it was coming.
Okay. That was my apology for the poor communication there. But like, so okay, a ball means kador, and so it could mean a thing that can roll.
Yeah.
And so if I was going to look at this particular one line of text, and look at what it says, like right before ball, it says, he will surely violently turn and toss thee like a ball. So when I think of that, I think of like if you had like a saucepan or something with a ball in there, and you're sitting there and you're shaking the saucepan all sorts of directions and everything, and the ball is able to move no matter how you turn that pan. The ball is rolling and moving and turning along from any direction. Whereas if you had like a cylinder or something, it's only going to be able to roll with certain tilts. But if you tilt it another way, it's not going to roll anywhere. So this seems like he's describing an object that can toss and turn no matter what orientation it's thrown about. So
right,
to
I'll
me,
give that to you, but here's the thing. The context here is showing you an image of a person throwing a ball. So you know that it's that image is going to require for that ball to roll because someone's throwing it, right?
yes.
Okay. Now that's a completely different image than what Isaiah 40:22 is giving us. Isaiah 40:22 is not giving us any motion. It's giving us a static picture of God above, no matter how high you want to say he is, looking at the earth. What does he see in that static picture? He sees a circle. Period. That's all it says. Now,
Which
if you
he
want to
would
start
if the
talking
earth was a
about
globe.
balls and rolling and stuff like that, yeah, now we're in a different picture totally.
Yeah, because they're different books from Isaiah. They're 18 books apart, so they're different contexts and circumstances. But I think in 40:22, I feel like he would, if he was trying to describe the cosmology of the earth and what God sits above, I feel like if he would have called the earth a ball here, it could have been a sort of divine revelation that, he said the earth was a ball here, and then a couple, years later, the Greeks figured it was a sphere because of bottom-up disappearance or Eratosthenes' experiment.
Yeah, well, maybe next time we write the Bible, you can suggest that to God. But what I would say now is whenever things are in motion, that's when Kador is used. When things are static, that's when circle is used. And that's why it's used of the heavens, because they're static. They're not moving.
The heavens are not moving?
Well, I mean, relatively speaking, they're not moving. Yeah.
Well, isn't like we're both geocentric, so don't we both claim the sky to move?
Yeah, I'm not saying the sky doesn't move. I'm just saying it's giving us a static picture. It's like if you took a picture of the heavens and you said, okay, what is this? Well, that's the circle that the word Coog is trying to describe here. Okay. It's not trying to deal with motion at that point in time. It's just dealing with what are we looking at? That's all.
Okay. And yes, and a globe, I do agree. Like a globe would look like a circle from any snapshot angle view of it.
All right.
So okay. Do you want to, should we go to the next verse?
Yeah.
Yep.
Go ahead.
Okay. So what I have here next is Job 38:14. So Job 38:14 reads, "It is turned as clay to the seal, and they stand as a garment." So Job talks about how the earth is turned like clay being pressed by a seal, and that the earth stands like a garment. And so if you look at like this example of on the right side of what a clay seal press looks like, this is what you used to seal envelopes with for letters and everything. And so you press a stamp down onto a pot of clay, and it flattens out. It creates an imprint in the middle, and then it kind of creates like that upturned edge. And similar with a garnet as well, you have this kind of flat shape with a circular shape with upturned edges. And so that I believe as well is showing a description of a circular, flat, pressed earth. These are just a couple extra depictions. The UN flag actually has like a quote unquote flat earth model map in its logo. A few other government organizations do as well. And then you have like another different depiction of a flat earth. I don't really subscribe to that bending, curving contour. I just showed it as to kind of show the depression, like a pressed earth. But that how do you say to this verse as a pressed seal?
Okay, so let me do something different here. I'm going to read a paragraph from my book that deals with this passage. Okay. As a matter of fact, I have one of the same pictures that you have there. I have the one that's the red one with the S on it. That's in my book. So, all right.
We're on the same page.
Yeah. All right. So let me restart reading it here. It won't take long. This passage is used to give the impression, that is you're trying to give the impression that like a seal which is flat and has demarcations on its surface, so the earth is flat and contains distinguishing features on its land. Suffice it to say, that is not the meaning of the passage. The original Hebrew does not say it is like clay under the seal, but it says it is changed like clay under the seal. And then I give the Hebrew.
So how does clay, if you have a pot of clay and you press it, what changes in the clay? Like, how does its shape change if it's pressed?
I will explain that in the next sentences.
Okay.
In other words, the clay is changed because a metal casting is pressed into the clay to make an impression. The word like before the word clay shows that the passage is giving an analogy, while the verb, it is changed, that's the verb, it is changed, shows that the clay goes from one formation to another. Likewise, the phrase following, a garment like they appear, is also an analogy, since the garment is changed from one color to another. The purpose of the analogy, in line with the context established by verses 12 and 13, is that as God shakes the wicked from the earth from day to day, the result is that the earth is changed as a seal is reformed by its press, and a garment is given a new color from its dye. As such, there's nothing in these verses which either explicitly or implicitly regards the earth as a flat disk. Both analogies refer only to change, not shape. Make sense?
Yes. Yeah. Okay. So yeah, this would be something that contextually, it's talking about change of like people or how things can change. Like if you have just a shapeless, not really shapeless, but like a detailless kind of smoothed over ball, you put it on something and then press into it, it's going to change its shape. It's going to change its defining features. It's going to change how it looks, but that it's not talking about the earth. It's talking about change itself.
Right. Yeah. And basically shaking the wicked out. You know, how's God going to deal with the wicked? And here's how he does it. He does it like as if you were going to press a hot metal into a plastic mold, and you see the mold going in all different directions. That's how he does it, and as an analogy.
Yeah. Okay. And I get how that could make sense, because there is metaphor in the Bible, like to help get, or there are analogies and stuff as well. It's to help get a visual, or to get a concept of what of change, or what is trying to be implied by any particular verse. So okay, all right. Then I think we kind of have covered this one. Should we go to the next?
Yeah, feel free.
Okay.
I've only got 15 minutes. Well, actually, I'll have to go longer because we have questions coming up too. So, yeah.
Okay. I will. I'll kind of hurry.
Yeah. Why don't we do a power round with the last verses? Correct me if I'm wrong, Nathan. The first one, which was 2, was technically 1 because you're using a supporting one. This was the second, and so now, did you want to do just one more and then jump into audience? Maybe a short closing and then audience questions, or
can I suggest one that you do?
Yeah.
Revelation 6:13.
You want to go to Revelations?
Yeah.
Okay. Yeah. So okay. So Revelations, the last 2 verses I have here for anyone, if you want to pause on this, is 1 Samuel 2:8 and then Acts 7:49. So those are the other 2, but for truncation purposes, so I'll go right to Revelation. So Revelation 6:13 is the last verse that I had posed, and it says, "And the stars of heaven fell unto the earth, even as a fig tree casteth her untimely figs when she is shaken of a mighty wind." So, like how leaves fall from the tree above to the ground below, the Bible says that the stars above will fall down to the earth. If the stars are small, this could happen. According to the size and scale of a globe model, our sun alone would vaporize the earth, as it is foretold to do so in roughly 5 billion years. So down on the left here, I have a to scale size, not to distance, typical heliocentric size representation of the sun and the earth. So the sun alone, you can see, would completely dwarf the earth and engulf us. And in 5 billion years, heliocentrism predicts that the sun will expand into a red giant and eat us anyway. And so then on the right side here, it's kind of blocked on my screen with this sharing screen thing, but there's a very, very small dot, which is our sun, compared to some other supposed size suns like Betelgeuse. There is actually a claimed red giant, and Tauri's is massive. So if these things were to fall to the earth in a literal sense, that the sun alone would completely cook and do the earth in. And so I think this is the last little bit I could throw in here, because this is, maybe I'll throw that in my conclusion. So I'll go back to here, and then if you want to talk about we can cover this.
Okay. So how I would explain this is, first of all, the Revelation is a symbolic book, and Revelation chapter 6 is no exception to that. But there is an eschaton, there is an end of the world. And if there's one thing that is pretty clearly literal in the apocalypse, it's when it starts talking about the end of the world, because it gets pretty graphic. And so this one, because there's a mixture of symbolism and literalism in the apocalypse, and this would be one of those cases where, even though it's using figurative language, like the fig tree and all that, well, we know that it's talking about a literal event that's eventually going to come. So if we believe in geocentrism, right? Okay. Correct. So that means the earth is in the middle, in the center. All the stars and everything else is out there somewhere. And we believe that they're a long distance away. Now, we can argue about how far away they are, because Big Bang advocates need them to be very far away. They need the universe to be 93 billion light years in diameter. Okay. We don't need that. So we don't use redshift to calculate distance. The most we will use is stellar parallax. Stellar parallax will take you out to about maybe 6 billion light years, if you believe that light stays at the speed of c. Okay. So it's a very different than the Big Bang model. So, but even then, 6 billion miles in radius is a long way. Okay. So if the other thing we need to know is that this passage in the Greek is not saying that they fell unto the earth. It says they fell toward the earth. Toward. Toward. Okay. So we can imagine that happening at the end of time. That if God starts to collapse the universe on the last day, that all these stars, if that's what he desires, start falling into the center of the universe. Where else are they going to go, basically? If they can't go outside the universe, so they're going to fall into the center. That's where the earth is. So they are falling toward the earth. Okay. Now, if it just so happens that it goes on long enough where the stars actually meet in the center and the earth is in the center at that point in time and it evaporates, well, that's exactly what the Bible predicts. In 2 Peter 3:10-13, it says that fire will destroy everything, including the earth. and God will recreate new heaven and new earth. You wouldn't have to create a new earth if the old one was still here. Okay, it's going to be new because the old one's going to be destroyed, and that was precipitated by the fact that the stars collapsed into the center and did exactly what Revelation 6:13 said. They fell toward the earth like a fig tree casteth her untimely figs.
Okay. Yeah, and amen to the new heaven and getting to live with our King and our Creator.
Yes.
Certainly. So I did want to call something out there. I did. You had mentioned parallax and how it would put the stars at a distance of approximately like 6 billion miles.
No, light years.
Or yeah, 6 billion light years. So I actually in my
Actually, no, that's wrong. It's 600. It's 600 light years. It's not 6 billion. I'm sorry.
600 light years. Okay.
Yeah.
Okay. Just because in the I'm taking an astronomy class right now, and it's actually like what I was taught was that there is no parallax we can observe with stars. That they're to try to make parallax calculations and things, you have to like assume distances. Like for example, typical heliocentric is like the sun is 1 astronomical unit or 93 million miles away. So they say that the Earth is 93 or at one time of year it's 93 million miles away from the Earth. Half a year later, it's on the other side of the sun, 93 million miles away. So you have like 180 million mile side if you put those 2 points together, and then you would look out at a distant star and you have to assume the distance. But you're essentially, I think the example given is like if you look at the closest star, you're trying to determine parallax from if you're on a rooftop, like a 10-foot rooftop in Louisiana, and you're at one edge of the rooftop to the other. If you're looking at something all the way up in Chicago that's like the size of a dime, you're trying to determine how much a different in apparent motion it is from one guy on the right side of the roof to the left side of the roof looking at that dime in Chicago. And if you can see that dime, one, the Earth is flat, but other things get in the way. But two, if you could see that dime, they probably would have a very difficult time determining any difference from their apparent position between one another at the edge of these 10 feet, looking at that dime. So parallax is actually it's not like we can't see it. A part of the sky appearing static and everything with special relativity and everything looking like it's non-moving, continual, cyclical. I don't know how far away stuff is on a flat Earth, like how far away stars are and whatnot too. So
this isn't going to affect our interpretation of Revelation 6:13, but just for the sake of knowing the ins and outs of parallax, you can see distances created between stars on a horizontal level, like when Bessel discovered that Cygnus 61 was closer and thus moved to the left or right of a star that was behind it, and he knew the star was behind it because it didn't move, but Cygnus did. So it's just a matter of measuring how far Cygnus moves with a star that doesn't move. And then you can use the Pythagorean theorem and determine from the angles what the distance, what the hypotenuse has to be. So that's basically how parallax works. I don't see anything wrong with that. But if you're saying that distance that Cygnus moves against the background star is too small, which is what I think you're saying, that it's too small to even measure, I don't know. I don't think I would agree with that. I think it's big enough to measure, but there are limits, I would definitely say, to parallax.
Yeah, and for the audience sake, just if I could just clarify, like what parallax is just to help complete the picture that we're talking about here, is if you were, say, driving in a car and you looked out your window and you saw street lights very close to you or telephone poles very close to you, And then off in the distance, you saw like a lone tree. And then behind that, you saw further away, you saw mountains. The telephone poles that you pass would be passing by your vision very quickly, compared to the tree that's a little further away. It would appear to move a little more slowly through your field of view. And then the distant objects, say mountains, would appear to hardly move at all. And it would take a lot more travel to see a motion of the background of mountains. So it's talking about the motion, because distant objects move slower to our eye, to what we see as far as apparent speed in our field of view. So
very good.
Sorry, Donnie, were you gonna say something, or did I interrupt somebody there? I think.
No, I was going to jump in if you both felt like we've covered each of the major topics thoroughly enough. I believe we have. In order to make it as complete as possible, would you both like maybe a 2-minute each summary of the debate itself? Then we can jump into 20-ish minutes of audience questions and wrap things up at, let's say, the 2.5-hour mark. But it's
I don't need a wrap up. I don't know if Nathan does. I assume go right into the questions because my time is limited.
Sure. Yes.
We can do that. If your time is limited, maybe Donnie, could we hop into Q&A, and then I could maybe give a brief conclusion at the end, just so I don't want to take too much time or anything. So if you're okay with that, Robert, if I would give if you do have to leave, I'm not going to be trying to like make a dig against your position or anything. I just would give my conclusion.
Well, I'll jump in. I don't want anything additional said after any of the debaters are gone. So what I can do is I will minus 2 to 4 minutes from the audience Q&A, just so you both have a couple minutes each to wrap up your thoughts at the end. And then when we shut down the debate, we'll all shut it down at the same time. Okay. So let's, so let's jump.
I just have a brief biblical thing towards that I wanted to kind of add as against a globe. But yeah, I'll just need like a minute too. So I won't need long, but go for it, Donnie. I'm sorry. I'm being difficult.
No worries. Very good. You both were very cordial, very easy debate to moderate tonight. You both gave me a easy job. Excellent debate on flat earth. Actually, Dr. Sungenis, a couple questions in the chat, and then also a question for myself too. What's the best way to get a copy of your book on the topic? Is it through your website?
My website, flatearthflatwrong.com. So that will be flat earth with no slashes or anything. Flatearthflatwrong.com is still available.
Tell us how you really feel about the flat earth, Robert.
Well, I almost let that website go. So I don't know if I paid my $19.99 for it or not this year. Anyway, so that's one. And then on robertsungenis.org, you can probably find a copy, or journeytothecenteroftheuniverse.com, you can find a copy.
Okay. All right, Robert.
Hey, can I quickly say something right there?
Yeah,
sure.
And anyone, Robert, the principal, fantastic, top physicist that can't get around the fact that the Earth, all experimental, and my professors have confirmed this too. Everything shows we're in the center of the Earth. A claim that science doesn't make. But Robert, again, dude's a maverick. He is just engulfing the flaw of the heliocentric, acentric cosmology. So the principal, fascinating documentary. Dude's incredible. Like so legit for that. So
great. Anyway. Thank you so much, Nathan. I appreciate that.
Okay,
it's been a rough road.
You're fantastic.
It's been a real rough road.
Yeah. Fantastic work on that.
I can't imagine you shaking the pot. You're stirring the mellow waters they don't want stirred. So
stirring things up.
Yeah, I know. It's good. We got the conversation started, right?
Yeah.
That's what it's about.
Okay.
Let's keep the conversation going too.
Okay.
Robert, and actually the first questioner, Jackson Rowe, I think we're in the beginning stages of setting up a geocentrism debate. So Jackson Rowe has the first question. And here's the question. I probably not going to be able to pronounce this right, but I'll try my best. How did Ratan 600 radio telescope, USSR, pick up surface experiment signals of the Apollo program in 1977? Anybody want to volunteer in terms of answering that?
No, I don't know. So
Yeah, I'm not too familiar with this specific example, but I've done some looking at like lunar range finding and everything, and bouncing signals off of the sky. And I do believe for a flat Earth, if you have a dome firmament, a crystalline structure, and then whatever the moon may be, that you can send a signal up. It'll travel through a different medium, which might slow the speed down, but it'll hit something and then send back. So I do think there is some ability to kind of bounce signals around off of something up there, like certain frequency, very high frequency signals, I think can be bounced and received back. So, but I'm not too familiar with the specific example from a flat Earth perspective.
Okay, thank you, Nathan. Robert, unless you had any thoughts, we can just move right to the next one.
no, let's just go to the next question.
Okay, super chat comes in from SoCal Preston, $5 super chat. I appreciate it. Question 4, Pitch Lumen. I'm guessing the P stands for. Okay. The Great Pyramid of Giza has numerous mathematical treasures that point to a globe-shaped Earth, not flat. Explain why.
So as far as pointing to a globe and not a flat Earth, so I think that there is something with the alignment of the pyramids, like the points are somewhat close to Orion, to the belt, or something like that, and there are shafts that point to certain stars. I think that there's a lot about like the pole star and shifting. If the sky can shift a little bit, it might have something to do with the fall and with the flood as well, causing a shift in like the magnetic fields. I think that there can be a shifting of sky, but I think that the sky has been able to, it's been predictable for so long that we, like flat Earth cultures of the past, were able to make predictions of the sky because they were flat Earth geocentric cosmology, so they were able to make these predictions as far as how the sky, if there's any little shifts or anything that have happened since then. But I don't think that the precession of the wobble of the globe there would be way more wobble than what we see in the sky over the 5,000 years since then on a 26,000 year cycle.
Thank you, Nathan. Robert, floor is yours.
I would just say I think the Egyptians thought that the Earth was a pyramid. That's my conclusion.
Appreciate it. Okay, very good, gentlemen. Okay, let's see here. Hymn's sake, super chat. Appreciate the support, and I think it's more of a comment towards you, Dr. Sungenis, and so we'll work through it, and then feel free to respond however you'd like to. And so the commenter says, if the Earth is a sphere with a radius of 3,959 miles, then every horizon distance measurement must be no more than 1.225 times square root of observer's height in feet. The black swan with horizon 9 miles at 1 foot debunks the globe. Any thoughts on that, Robert?
No, because I haven't the slightest idea what he's talking about. I mean, black swan and horizon.
Do you mind if I could share my screen? I actually have a picture I could show. If that is okay.
Sure.
Yeah,
I've
sure.
never heard of this black swan either, so that would be.
Yeah. Okay, there we go. Okay, so yeah, this here is the black swan. Let me see if I can full screen this somehow. This is the black swan here. This platform is this far away, this one's this far away, and then there's like a horizon line beyond it. But this is the picture that he is referring to. If you Donnie, if you want to reread the question, I can have this up for him so that he can if you want to take a crack at it, Robert, in this sense. Let me see if I can put this up and then put this down here, and then can you see the question and the picture at the same time?
I can, but I don't know if I'm going to be able to do this right now. This is going to take some calculations and some study, not something that I want to deal with right now. I would just like to deal with general questions about this topic. That if something wasn't clear, we can make it clear. If they need a little bit more information about something, but I don't want to be quizzed on something I've never seen before, because it's going to take some time to figure it out.
Absolutely, completely understandable. So let's move right to the next question. Richard Firks. Question for Dr. Sungenis. Could you explain the Hebrew word we translate as firmament and its nuances, along with your "there cannot be nothing" explanation?
Okay, very good. So the firmament is a very strange Hebrew word. It's the word rakia, and it has a root raka, and they mean similar things. But rakia can be used of something very hard or very soft. And we can get that from Genesis 1 itself, because the firmament in verses 6 through 9 is something hard enough to hold up water. And the firmament in verses 14 to 19 is something very ethereal that houses the stars and the sun and the moon. Okay. And we know when we look out there, what do we see? We don't see much except celestial bodies. Okay. So we don't see something hard. So that's the mysterious part of this word rakia, otherwise known as firmament. When I did my study on this, and actually it's in this book, Flat Earth, Flat Wrong, I examined, I think, 42 different New Testament and Old Testament translations. And I got, how many? Was it a dozen different English words were used to translate this word rakia. Firmament, I think, took up 12 of the 42. Another one that was not as solid was expanse, because an expanse is something that's expansive. It's the heavens. You see, so they got caught, because firmament means something firm. Expanse means something ethereal. Expanse got 11 of the 42 translations, whereas firmament got 12. So those were the most, 12 and 11, between firmament and expanse. Okay? So it tells you right away that we got a problem understanding this word. Okay? It's very strange. And then there was one translation, what was it called? The Christian Bible translation, something like that. I forget. It's in my book. And it didn't know which way to go, between something firm or something ethereal. So it said something. God created something on the second day instead of saying firmament or expanse.
Okay.
Can you imagine?
It's something.
God created something.
Just throwing something.
Yeah. And then there were words that were like halfway between firmament and expanse, if you can imagine that. Okay. And these are scholars. These are Hebrew scholars. They don't know which way to go on this word, right? Because you got two different explanations of it in Genesis. One's something hard that can hold up water. The others where the stars and such are situated. Okay. So I go through a lot of that word, and I show, look, you can't say that it's a hard dome. That's one thing you can't say. And the liberals love it when we do that. I just want you to know that. They love it when we do that, because what they say is that the Jewish writer of Genesis got that information from some Mesopotamian pagan culture over here that thought that the earth was flat and there was a dome over it. And so without thinking, the Jew just took it from the Babylonians, put it in his Bible, and put Yahweh in there, and everything was fine because Yahweh made it, even though he got it from these pagan people over here who didn't know anything about cosmology. All right. So they love it when you guys talk about, flat earth and a dome over it, because they say, yeah, you're just as primitive as the Mesopotamians were. So I get away from all that stuff and I say, no, the firmament was something that held up the water, and then there was an explosion. And that's why the Bible talks about the firmament expanding. There's 10 passages in the Bible that talk about the firmament expanding. And when it expands, it's going to diffuse. And it's going to take all the water with it, and it's going to diffuse so much that by the fourth day, it's diffused enough where it now becomes something ethereal, whereas on the first day, it was something very solid, or the second day, I should say, was something very solid and strong. And now it's ethereal enough that it can take the stars and the sun and house them. And that's what we see today.
Can I ask, where did the flood waters come from? But like, there are some from the great deep below, but like, were there waters above, like in a canopy or anything above the atmosphere, like above the exosphere or anything?
Well, all we would have to, you don't need that. All you'd have to see, what they know today in science is that there's 3 times as much water under the earth than on the earth. Okay. That's 3 times as much water as we have in our oceans. Indian Ocean, Pacific Ocean, Atlantic Ocean. 3/4 of the earth is covered by water. And they say there's 3 times more of that down below.
And that's surface water today. Whereas also the Bible does mention that pre-flood, the mountains were not quite as high and there were not as deep of valleys. So there wouldn't need to be as much water to cover the entirety of like the highest mountain, as the Bible mentions.
Yeah, that could be. But what I'm saying is there's enough water there to flood the earth, 4 times over. We don't have to worry about where the water comes from. And as a matter of fact, if it came up from the surface, then we would expect it to be exploded from beneath and then rise miles high, all this water vapor. And then what's it going to do? Then it's going to eventually fall down, and it's going to rain for 40 days and 40 nights.
Mm-hmm. Yeah. And, okay. I was just curious about that. And I like can I have like a quick rebuttal to that?
Yeah,
sure. Go ahead.
I do like, as far as like the firmament being hard, I don't think that the flat earth doesn't have a problem with that, because that is like, there's a physical, like the Bible talks about that the firmament is like molten glass, like it's pounded, like sapphire. So those would fit in with a flat earth cosmology, as well as like an etheric expanse, like what is above. Like if the firmament is like this, then above is water. And my interpretation biblically is that above us is water, and then that's where these stars are. And so they're either in the glass or above the glass behind it. So the light's traveling through the glass, but that would be like the etheric realm of the firmament, and the heavens above. I think it would be the second heaven. And then the third heaven is where God would be, like his heaven, the kingdom of heaven. But that would, I think, just be my response to like the flat earth explanation for a firm firmament and an etheric firmament.
Yeah, but here's the problem with that, if you want to discuss it, and that is verses 14 to 19 say the celestial bodies were put in the firmament. It's ba-rakia, okay?
In the glass. Okay, so in the glass.
And so you can't say that they're outside the firmament or above the firmament. The Hebrew language says they are in the firmament. Okay.
Okay.
So yeah. If your firmament is solid, how's it going to take and it's going to have to be pretty big too. How's it going to take in all those celestial bodies? You see?
Yeah. And that would be, so for context, a flat earth cosmology says that stars are not massive, way bigger than the earth. They're very small points of light. And so maybe if there's like a thickness to the firmament, the light could be in the middle, and then in that firmament band that kind of domes down. And that could also be expanses. The firmament in the cosmology is the biggest part of creation because it covers all of the earth, even to the edges. So it would be the expanse of the firmament. And then in that, like if you have like a 8-inch thick firmament. If there's the point of light originating in there, and then also in that is water in the medium, and then there's the glass on the bottom and the glass above or something like that, that would be in the firmament with liquid, with light.
Yeah, but here's the problem. That's not what we see in the sky. All we see are the stars. That's it.
Is light. We see, and that, but that's the flat Earth claim, is that
But if they were reflecting off the firmament, we should be able to see the firmament because it's reflecting light. But we don't see that. Just like a rainbow reflects light, we can see the rainbow.
Well, a rainbow does reflect the shape of a dome, and
yeah,
it
I know
has
that.
like prism and everything. So,
all right.
Okay, let's give Robert the last word. It was his question. Go ahead, Robert.
Yes.
No, I'm done. Let's go on to the next question.
Okay, gentlemen, great back and forth. Great question as well. Okay, SoCal Preston, question for Robert. Explain how Eratosthenes proved the Earth is Eratosthenes. Say that 10 times fast.
Yeah.
Eratosthenes proved the Earth is not flat with his experiment, and how flat earthers co-opted geocentricity.
Well, I have to attribute this answer to the late Rob Skiba, who had an excellent answer to this, and which was, yes, Eratosthenes could do what he did, but he assumed the Earth was moving or rotating and the sun was fixed. Okay. Now, if you assume that the Earth was fixed and the sun was rotating, you're going to get the same effect that Eratosthenes got, but it's going to be from a geocentric perspective. Okay. Because just as the Earth can rotate, so the light can move too. It's not just you can't assume the light's going to be staying fixed and the Earth is going to be moving underneath of it. That's the whole problem with Copernican cosmology, is that they assume as fact something they haven't proven yet.
Lots of assumptions.
Yeah, and that's probably the biggest one. So I couldn't do that. Now, it's possible that instead of setting up 2 light receptacles as Eratosthenes did, you set up 3 or 4. Now there you might have something there, because each of those light receptacles is going to show a different angle of incidence for the light, and whether the sun can cover all that and make all those angles, well, that needs to be tested out. But so far they've only done it with 2 light receptacles, so that's where I'm going to answer this question.
Eratosthenes would have enjoyed this debate, gentlemen. I can guarantee that. So, Nathan, any thoughts from you at all?
Yeah. So the Eratosthenes, his the story is that he planted sticks in, or there was a well in, I think, Cyrene, and then he had a stick in Alexandria, and he looked at over the well. The sun was directly over the well, and so if you look straight down, you would see this. There would be no shadow because the sun is directly above the well, and then the stick is 500 miles away, and it casts a shadow that's this long. He must have been communicating on a cell phone with someone 500 miles away on the same day at the same time, because they took the measurements, and they said that we can calculate that the Earth, if the sun is this far away, we can say that the Earth has a circumference. And I think he got within 5% of what is the claim of the equator today. But that experiment can actually support a close local sun on a flat Earth as well. Getting multiple data points is important if you're going to look at sun observations and the shadows they cast. I have seen anti-flat Earth channels that try to recreate Eratosthenes' experiment. They use multiple data points and observers from the north, from the south, from the equator, and everything. There is kind of a variance in there. It's not consistent. Like the further out you go away from the equator, it's not always a steeper angle that it should be. There are sometimes people that see it closer or distant. Yeah, it's assuming shape, it's assuming distance, assuming size. There are a lot of assumptions that go into that, but it's mathematical. So you can use Eratosthenes or these sun observations, and as long as your sun is scaled, distance, and size. So it always has the same apparent size. You can get the same shadow casting. But yeah, a flat earth has to, pretty much has to be geocentric, and it can't not co-op it. I mean, there are some people that say like the earth is always rising, but take a biblical position and an empirical position that we measure no motion. So that's, I am on the side that there's no moving earth. So it would have to be the center, because the sky moves, like Robert said. One could move, the other could stay still, or vice versa. That's actually special general relativity as well, why we don't detect motion.
Yeah, it's relative motion. Donnie, I have to go, so I'm sorry.
No, that's okay. We'll wrap it up there. Anyways, that was 20 minutes of audience questions. Gentlemen, appreciate you doing this debate. I think it was an excellent debate. And if you both wanted 10 seconds of final words, feel free to go ahead, and we'll just shut it down at the same time. This was a great debate, Nathan and Dr. Sungenis.
I just want to thank you both for hosting this and participating, and it's been very enjoyable. I loved every minute of it. And Nathan, I hope to see you again sometime else, somewhere else. And Donnie, you know where to reach me. Okay?
Yes, I do, Robert.
All right.
Thanks for your time. You enjoy your
right.
night and the rest of your week. Take care. Bye.
Take care, Robert.
Nathan, final words?
Yes. Donnie, really, thank you, brother, so much for putting this on, making this happen. Robert is an incredible guy. I really enjoyed this as well. The principal dude crushes it with geocentrism, and that the earth isn't moving. It's just a matter of the shape of the earth. But Robert is a really good man. The stuff that I wanted to add, like that was at the end of my presentation, was something that kind of goes biblically with a globe, for like a traditional heliocentric model globe with its tilt, with its size and everything. The globe does claim that the earth is tilted at 23.4 degrees on its axis, and then that axis has that precessional wobble of 26,000 years. But if you look at 23.4, 90 degrees in math is an angle that's straight up. So if you take that straight up right angle, 90 degrees, and then you tilt it to 23.4, what you're actually left with is 66.6 degrees. Not only that, the earth is supposed to be orbiting the sun. Not that
Nathan, I just want to jump. I want to make sure you're not bringing up any new arguments or response, because Robert's not here anymore. So just quick final words, final thoughts, but nothing like, I don't want you elaborating on anything. Gotcha.
Okay.
Yeah.
Then yeah, basically, I think that the observations, the experiences that we have, the experiments that we can recreate, demonstrate on scaled recreational models using realistic conditions and variables, I think they indicate that the earth is planar, and that we can see too far in hot and cold conditions. So yeah, I do think that, I think it is biblically supported as well, or fits in line with what the people of the time believed. Ancient cosmologies were flat earth cosmologies. So that's, I guess, the rundown that I'll give. And then, yeah, really thank you so much, Donnie, for this and for this opportunity. The principle, y'all, very good, from Robert's work. But yeah, that's about all that I have. I'm sorry I couldn't answer any of your questions, but if anyone wants to ask me anything, please feel free to reach out. But yeah, Donnie, really thank you so much. And Donnie, you do great work as well with dismantling evolution. You really put it to them. So yeah, I really do want to thank you so much for this. I can't express gratitude enough with my poor English. So
well, I appreciate the kind words and the compliments, brother. It was great having you on. We're definitely going to have to schedule some more debates on this topic with you in the future. I look forward to that. And you and Robert made for an excellent debate, a debate to remember. We've had a fantastic audience the entire time with questions that could really keep us busy till same time tomorrow night. So Nathan, we'll wrap it up there. Again, I appreciate you doing this. This was an awesome debate. Our first flat earth debate on Standing for Truth Ministries. We've hosted now about 350 debates on all sorts of topics, and this is the first for flat earth. And you and Robert did not disappoint, and that's the kind of debate I would want. on this topic is a debate, not just between a couple guys off the street duking it out, but between two people who have actually studied this and who have actually put in the time, effort, and energy to make for a good, edifying debate, Nathan. So thank you. Dr. Sungenis, thank you as well. And so, Nathan, I'm going to let you get out of here, my good man. I'm going to stick around for a few minutes as I typically do and just go over some announcements and reminders. So, Nathan, again, thanks so much and God bless.
Peace and love, brother. God be with you all. All glory to the Most High. Jesus is the Savior and he loves us all. We're all so special. God is amazing.
Amen.
Peace
Well
be
said,
with you.
Nathan. You have a great night. Okay, well, there we go, everybody. Another one in the books, and specifically a flat earth debate in the books. Last month, we did a debate on geocentrism with Dr. Robert Sungenis. And this month, we did a flat earth debate. And so when it came to these topics, great, interesting topics, I wanted to make sure that I had informed interlocutors because I wanted these debates to be edifying and educational for the audience. And Dr. Robert Sungenis obviously knows his stuff on these topics. Nathan Erickson, he's put a lot of work into studying this topic as well. And so I believe they truly gave us an excellent debate. And so Doki Doki Bible Club, I appreciate it, brother. SFT Ministries website. So I'm glad that you brought this up, the website. Please do check it out, everybody. Standing for Truth Ministries .com. I've been working with our website designer. We are revamping the website. We are adding a whole new comprehensive section titled Visiting Guests or Visiting Scholars on Standing for Truth. And it's just going to be a long list of a lot of the creation scientists, a lot of the guests that we've had on, the informed guests. And you'll be able to click each guest and it'll take you to a separate section where you can find all of their lectures, presentations, their shows that they've done with us. And so I think that is going to be a great resource for people to utilize. And you'll find just dozens of guests on there focusing on all sorts of topics. And so it is a lot of work. Revamping the website, adding all these different avenues through the website. And so my guess, probably sometime within the next week, that should be ready, but I'll let everybody know. But still, currently, standfortruthministries.com, you're going to find endless content there already. We're also going to be altering the homepage a little bit because I do have quite a bit on that homepage for people to check out, but I'm going to condense it a little more. And the website designer and I, we are going to have more links on the homepage. It'll take you to other pages where you can find your preferred content. So please do take advantage. Okay, let me also go over a few reminders, as September has been no different than the summer in general. We've had quite a few epic debates in September. We've got several main events from now till the end of the month. And that includes this one. This was an awesome debate. Tomorrow, we've got a debate that I've had scheduled now for probably about 3 or 4 months. And it just shows me how quickly time goes by because it's already here. The Great Millennium Debate, Dr. Don Preston, leading voice in the world of full preterism, and Pastor Anthony Aquino, who's done numerous debates on eschatology related topics. And so it is essentially a guarantee that this will be an epic debate. This will be another debate to remember. And this will be a comprehensive debate on the millennium. The Great Millennium Debate is the 1,000 years future. I am excited for this. It kicks off at 8 o'clock. 8 o'clock EST. Doki Doki Bible Club, appreciate it. Patreon. So for only as little as $1 a month, you can become a Standing for Truth Patreon patron. And I have specifically 2 new series that I am working on. One is the Endogenous. One is a walkthrough of my book, The Endogenous Retrovirus Handbook. And it's a walkthrough rather than a strict audiobook because I provide commentary. I cover various points in terms of my active research project on the endogenous retroviruses. That includes addressing criticism, answering questions and challenges from skeptics and those that have challenged points in my book. And then I'm also doing a series debunking William Lane Craig on theistic evolutionism. And so the next episode, I'm hoping I'll have available sometime in the next few nights. And I've put out episode 1. It's getting great feedback on the main channel, 3,000 to 4,000 views or so far. But if you're a patron, you get early access to every episode in this series. And both these series, I think, are incredibly important. The endogenous retrovirus topic, for example, evolutionists claim that endogenous retroviruses are the number one line of evidence for common descent. And so I want the body of Christ, I want my brothers and sisters to be well equipped to engage that topic. William Lane Craig, well-known Christian theologian, but also theistic evolutionist. I am tackling his best so-called arguments for evolution. That includes homology, that includes pseudogenes, junk DNA, nested hierarchies. And so if you haven't yet seen episode 1, it is available on the main channel publicly. Again, if you are a patron for as little as $1 a month to help us continue doing this full-time and providing you full-time content, roughly 4 to 5 events a week. If it's on your heart to support us, please do. And again, you'll receive early access to these important videos. And okay, so what else do we have coming up for you? Well, we've got quite a bit. As a matter of fact, we got 3 in a row. So right now, Flat Earth on trial. Tomorrow is, again, the Great Millennium Debate. And then the next day, Saturday, is Steve Christie versus Fro. And so they'll be debating the question, when was the Old Testament canon settled? And I think that one's going to be an excellent debate, a very interesting question. We haven't actually debated that on this channel before. So that is coming up on Saturday. Then at the end of the month, we've got a few debates you're not going to want to miss. Kelly Powers from Berean Perspective Apologetics. He'll be debating Sean Griffin from Kingdom in Context. The question is the Trinity biblical? This is going to be a huge debate. It's going to be an epic debate. You don't want to miss this one. This one is going to be at 10 o'clock, either on a Friday or Saturday. Check the main channel. I do have them all posted for everybody to see, and hit that notification bell. It'll start at 10 EST. Earlier in this same day, I've been working with Paul Price. Paul Price recently engaged in what I believe is an open mic debate that everybody needs to watch on genetic entropy and the mystery of the genome. It was an epic 3 hours. Sam and I hosted and engaged in a little bit of debate too, but we had numerous PhDs from the evolutionist camp. We had Dr. Dan Stern-Cardinal, Dr. Zach Hancock, Dr. Joel Duff, Jackson Rowe was there, Grayson from Bayes Theory, Luca Medugno. It was a great turnout, great discussion. Dr. Zach Hancock, he put out a review of Genetic Entropy, the book by Dr. John Sanford. So he criticized it and he put out his own response to that book. And so Paul Price and I have been working behind the scenes to respond to his review. And so the same day, we wanted to squeeze it into September, and there's basically shows every single day in September, but we figured, you know what, end of the month, we'll have a review or a response to Dr. Zach Hancock all ready to go. And so we're going to respond earlier in the day. And then later at night, we'll have this debate between Kelly Powers and Sean Griffin. We got some eschatology fun for you as well. Kirby Tabb, pastors, Kirby Tabb and Scott Clem. Futurism versus historicism. I think this one is going to be an excellent debate. I'm currently working on a major panel discussion in terms of end times theology for October. And so I've got 5 or 6 guests, all kinds of views in the world of eschatology. They've all agreed to participate in an important panel discussion on the topic. Just working at picking a day and a time that is convenient for everybody, scheduling wise. Okay, what else do we got here? This is just a snapshot, really, of the overall material that we have for you here on Standing for Truth. Next week is going to be a lot of fun in terms of not necessarily debates, but discussions on various creation versus evolution topics. Okay, so we have Dr. Peter Line. I cannot wait for this. This is going to be a very interactive show. So Dr. Peter Line, he has written a ton on the topic of human evolution. You can find a lot of his articles over on creation.com. And so Peter Line and I have had some good back and forth. Dr. Peter Line and I have had some good back and forth through email, and we are going to comprehensively examine the hominin fossil record. That includes the Australopithecines. That includes examples from the Homo genus like Homo naledi. And Dr. Peter Line is going to come equipped with fossils and props, and it's going to be a very edifying show, I think. We're going to do it live. And so for critics and non-critics, as usual, make sure you are here for that show, as we will be engaging with you and we will be taking audience questions and addressing audience challenges. And then I had Dr. Helmut Welke. So here, Helmut Welke, he's going to be giving a presentation. I'm just double checking. September 25th. So in about 10 or 11 days. And I had a good talk with him, as he has a good series of presentations. And so I want him to, it's going to be edifying to have him on over the next few months, giving several of his presentations. But his first one that he's going to give is a presentation on a topic we've never really touched on here on Standing for Truth. It is aliens, UFOs, and the Bible. I mean, what a great topic, especially in light of everything going on in the world and aliens and UFOs being such a major topic that people are discussing, including in movies. We've also got a couple more open mics too. And so T-Rock, he's been working, he has an active research project, I could say, on the flood and specifically the ordering of the fossils in the rock strata. And so he's been working a ton on a model explaining the ordering of the fossils from a young earth creationist perspective and model. And so he is going to present his model. He is going to present a lot of his work and data points on September 20th. And then we're going to open it up for an open mic debate. And so all you evolutionists out there, yeah, I'm talking to you, Jackson Rowe, in the live chat. You better make sure you are here for that open mic. Again, it's the 20th. And I think that is going to be a great show, as the flood in general is controversial, even in the young earth creation world, as there are various models. You've got catastrophic plate tectonics, hydroplate theory, vertical plate tectonics. And T-Rock, he is going to give a great presentation, and then both creationists and non-creationists alike, feel free to join, and we'll have some excellent impromptu debate. For those wondering when our next major evolution debate open mic is with Dr. Dino and all of the critics that join, that is going to be Thursday, October 5th. And so we've just got so much in September. I really wanted to fit the next one into September, but there's really just almost no days available. Over the course of the summer, we did a major evolution open mic. Basically, every single 10 days, we went sometimes between 5 and 6 hours. We talked on a number of awesome topics. And so the next one will be October 5th. So we'll kick off October with a bang. Luca Medugno for the first hour debating Dr. Dino. And then we'll open it up for another roughly 4 hours of open mic debate. So Redefine Living, my award-winning co-host brother, get yourself ready for that. And I think that's it. I'm going to wrap it up here. I wanted to give I wanted to devote a decent amount of time to reminders and announcements, because we have a ton going on at the ministry behind the scenes. Full-time study, full-time research projects, and I have been interacting with so many awesome people in terms of scheduling future shows, whether that's debates, we're starting to work on our Defending Genesis conference. This year, it'll probably be in November. Last year, it was in September. Whole week worth of shows, presentations. We wrapped up the week with an awesome debate, and we're thinking of doing the same thing in terms of conference structure this year as well. Okay, guys, with that, I appreciate everybody tuning in. Mitchell, you guys are the life and blood of this channel. So the only reason we're able to put out so much content and a lot of different kind of content. So whether it's books, debates, interviews, conferences, discussions, panel discussions, articles, it is because of our listeners. It is because of our supporters. Ultimately, we're a listener supported ministry. And so for those that love what we're doing, that appreciate the content that we're putting out, consider supporting us, because it is a huge help in our work here in defending the truth of biblical creation. So, okay, with that, I am going to officially wrap it up, share this content around. Critical thinking is important. The truth is important. And I really, really enjoyed this debate. I thought it was an excellent debate on the flat earth. And so with that, God bless all. Standing for Truth is out. We'll see you soon.